morning I'm going to attempt to lecture on section 4.3, and it's not a terribly difficult section algebraically, but conceptually it's kind of odd. It's on numbering and bases, and not that we would ever think about this, but the base that we live in on an everyday basis is we work in base 10, and the numbers that are permissible in base 10, the numbers that we use every day to make up any number, are the numbers 0 through 9. No matter what number you tell me, I can write that quite quickly in base 10. Like if you want me to do 76, I just write the number 76. And that's 76. That's not terribly difficult. We work in base 10, so we think in base 10. Occasionally, we want to restrict our numbers to fewer numbers or expand our numbering system to have additional numbers. And when we do that, we're working in a different base. Back in my day, when I first started using computers weren't that advanced, and when the programmers programmed a computer and told it how to work, they programmed in base 2. They programmed computers in something called assembly language. Basically, back in the day, a computer could either recognize that there was an electrical impulse or there wasn't an electrical impulse. And if a computer sensed the numerical impulse or an electrical impulse, it would consider that a 1. And if it didn't detect an electrical impulse, it would call that a 0. And using just the numbers 0 and 1, having an electrical impulse or not having an electrical impulse, programmers programmed computers to do everything they could do back in 30 years ago, which is fairly amazing. Technology has advanced a little bit, and currently, when programmers do the program computers how to work, kind of behind the programs that you might be running, they use base 16. And in base 16, we're allowed to use more numbers than in base 10. In base 10, we're allowed to use the numbers 0 through 9 to make up any number. In base 2, I could only use the numbers 0 and 1, and using the numbers 0 and 1, I'm supposed to be able to communicate. Base 16 is, in some sense, more powerful than base 10. We're allowed to use all the numbers from 0 through 9 that we use in base 10. But in addition, we have a number that stands for 10. We'll just say maybe A stands for 10. B stands for 11, C stands for 12, D stands for 13, E stands for 14, and F stands for 15. So in base 16, we have numbers 0 through 15 that we can use as opposed to just numbers from 0 to 9. This almost seems kind of pointless. It feels like the numbers 0 through 9 in base 10 are completely enough to do everything I need to do. Apparently, in the worlds of computers, if you're working in base 16, you could be more efficient and make the computer work faster working in base 16 than in base 10. So there are needs for efficiency purposes to have other base systems, and we'll just really briefly talk about other bases and not do too much with them, figuring that most of you probably won't ever have a need to use another base. More or less, if you're not really into computers, you won't see other bases. But nevertheless, there's a little write-up here that talks about numbering base systems and when they're used. And if you have the desire, you can print it out and you can read a whole bunch of junk that I printed out that talked about how different numbering system, different bases are used with computers. We won't go there. So what's important in this chapter is to understand that in different bases of numbers, only certain numbers are usable. So we live in base 10, so we could use 10 different numbers, the numbers 1 through 9 and 0. In a world of base 2, you're only allowed to have 2 distinct numbers to make up your whole language. In base 3, you're permitted to have 3 numbers in your language to make up everything that you want to make up. In base 4, you're allowed to have 3 numbers, and with those 4 numbers, you should be able to communicate perfectly well to somebody. If I had base 20, then I get to make up a bunch of new numbers that I just give letters, but you could actually give symbols. In base 20, you're going to have 20 different numbers, and because I only know 10 different numbers, 0 through 9, I need to make up symbols for, like, A might stand for 11, B might stand for 12, C might stand for 13, D for 14, E for 15, F for 16, G for 17, H for 18, and I for 19. There are 20 different symbols there, each representing a number. So not that it looks like it, but I represents the number 19 in my version of base 20. So what we're going to do for homework purposes is we're just going to get used to working with different bases. We're not going to do any algebra per se. I'm not going to add numbers, multiply numbers, subtract numbers, divide numbers. I'm just going to convert numbers from one base to another. And I'm going to stray from my handout quite a bit because I don't think I need my handout to explain how to convert from bases. So this is probably not a stellar lecture, but you don't need to understand bases perfectly to be able to convert from one base to another base. So I'm going to get into the text. And there are only 2 groups of problems that I assigned in section 4.3. The first problems ask me to convert a number that's given in another base and make it into a number in base 10. So in number 4, I see the number 60, and it says this is a number in base 7, and I need to convert it to a number in base 10. And this isn't terribly hard to do. To convert any number from one base to another base, we write the number in reverse. So I'm going to write a 0, and then a 6, and then next to each of the numbers written in reverse, I write a times sign, and next to that times sign, I put the base, and I put an exponent with the base starting at 0 and incrementing up. So to convert 60 base 7 into base 10, I'm going to multiply 0 times 7 to the 0 power and 6 times 7 to the first power and add the results. I don't really need my calculator to do this. 0 is just 0. Anything to the 0 power is 1. And in the next part, 6 is just 6, and 7 to the first power is 7. So 0 times 1 is 0. 6 times 7 is 42. 0 plus 42 is 42. I claim that 60 base 7 equals 42 base 10. So the answer to problem 4 is 60 base 7 is 42 base 10. And if I don't write a base with a number, it's just assumed to be 10. So I can say 60 base 7 is equal to 42. So I'm going to do a bunch of the even problems between 3 and 20, and probably by the time I've done the third or the fourth problem, you'll understand how to convert from one base into base 10, and maybe not understand why I'd want to do this, but the why is kind of harder to teach, and it really is for computer programmers. So for this problem 6, I'm going to take the 101 and write it backwards to convert 101 base 2 into base 10. I take the number that's given and write it backwards. And writing it backwards here, it doesn't look very different because it's kind of a mirrored image of itself. And then next to each number, I'm going to write a times a 2. In this case, it's a times a 2 as opposed to a times 7 because 2 is the base. And then I'm going to add exponents to the 2, starting at 0 and incrementing up 1 each time I see a 2. So 101 base 2, to convert it to base 10, I write the numbers 101 in reverse, put a multiplication next to each of the 1 zeros and the 1s, and multiply by 2 to some power. I'm going to put plus signs between these. Now I'm going to do the exponents because order of operations asks me to do exponents first. The first exponent I see is 2 to the 0, and anything to the 0 power is 1. The second exponent I see is 2 to the first power, and 2 to the first power is the same as 2. The third exponent that I see is 2 to the second power, and 2 to the second power is 2 times 2, and 2 times 2 is 4. So I wrote the number backwards, multiplied by powers of 2, figured out what the powers of 2 are. Now I'm going to do my multiplication. 1 times 1 is 1. 0 times 2 is 0. 1 times 4 is 4. Now I'm going to add the numbers together and get 5. So the answer to this problem, 101 base 2, is equal to 5 base 10. Or I could say 101 base 2 is equal to 5. I don't need to write the problem next to the answer. Just writing the number 5 would be sufficient. And if a number's in base 10, we just assume that the 10's the base and we don't write the base. So I'm going to do 8 and 10 on this sheet the same way. So if you're watching the video and you want to pause and do these yourself, that would be good. For each of these problems, I'm going to start off and I'm going to write the number backwards. So instead of 1101, I wrote 1011. And instead of 21021, I wrote 12012, writing the numbers backwards for problems 8 and 10. Then, next to each of the numbers, I'm going to put a times a base. In problem 8, the base is 2. So next to each of the numbers that I've written in reverse, I'm going to write a times a 2. In problem 10, because the base is 3, next to each of the numbers, I'm going to put a times 3. So I've basically done the same things for problem 8 and 10 to get started. I wrote the number backwards. And next to each of the numbers, I put times the base. And before I get into these problems, I need to put exponents with the base. I start with 0, and I work my way up until I'm done. So in problem 8, the exponents on the base is going to be 0, 1, 2, and 3. In problem 10, I start with an exponent of 0, go to 1, go to 2, go to 3, and go to 4. And now I'm going to put addition signs. Between the pieces. Then I'll do the exponents, and some of the exponents you might need your calculator for. If I didn't know that 2 to the 0 power is 1, on my calculator I would hit 2 and then the up arrow key and then 0. And that would be 2 to the 0 power. When I hit enter, it gives me 1. If I didn't know that 2 to the first power is 1, I'd go 2, up arrow 1, and hit enter and get 2. If I didn't know that 2 to the second power is 4, I'd go 2, up arrow 2, and get 4. And if I didn't know that 2 to the third power was 8, I'd go 2, up arrow on my calculator 3, and it gives me 8. So after I get the problem that needs to be reduced, I do the exponents first. So for problem 8, the 2 to the 0 was 1, the 2 to the 1 was 2, the 2 squared was 4, the 2 cubed was 8. After I get rid of the exponents, I do the multiplication. 1 times 1 is 1, 0 times 2 is 0, 1 times 4 is 4, 1 times 8 is 8, and then I add these numbers up. So 1 plus 0 plus 4 plus 8 is 13. The answer to problem 8 is 1101 base 2 is equal to 13. That would be all you need to write for an answer. It wouldn't be wrong if you wrote the problem and said 1101 base 2 is equal to 13. Then you don't need to write the base 10. 10 will work exactly the same way. So I wrote the number backwards. Next to each number I put the base. And then I put powers with the base, starting at 0, going until I'm done. And now I'm going to do the exponents. The first exponent, 3 to the 0 power is 1, because anything to the 0 power is 1. The second exponent, 3 to the first power is 3. The third exponent, 3 to the second power is 9. The third exponent, 3 to the third power is 27. You might need your calculator for that. The fourth exponent, 3 to the fourth power, is 81. So I set my problem up that needed to be solved with the exponents. Orders of operations want me to do exponents first, multiplication second. So I do the first multiplication. 1 times 1 is 1. 2 times 3 is 6. 0 times 9 is 0. 1 times 27 is 27. 2 times 81 is 162. Now I add these numbers together, and that's calculator worthy. So I'll just go 1 plus 6 plus 27 plus 162, and I get 196. So the answer to problem 10 is that 21021 base 3 is 196 base 10. And if you just wrote the number 196 and didn't write the base, that's preferred, and you don't need to write the problem next to the answer. There's 2 more problems on the next page, so maybe you can try to do those without watching the video, and then go ahead and check yourself. So I'm going to do 2 steps in one. I'm writing the number backwards, and I'm multiplying it by the powers of the base. So in this case, I wrote 456, which is writing 654 backwards. Next to each number, I wrote times 7 to some power, and I started with 0 and ended at 2. I'll do the exponents. Anything to the 0 power is 1. Anything to the first power is itself. And I know that 7 squared is 7 times 7, which is 49. Now I'll do the multiplication. 4 times 1 is 4. 5 times 7 is 35. And to be safe, to figure out what 6 times 49 is, I'll just multiply and get 294. And I just add the numbers up now. So 4 plus 35 plus 294. And I get, messed up, 4 plus 35 plus 294. So the answer to this problem is 654 base 7, or 654 base 7 is 333 base 10. And again, if I was writing an answer, I wouldn't write the problem with the answer, and base 10 is assumed, so I wouldn't write the base. To do problem 14, I'd start off writing the number in reverse. So I wrote 4 ones and 0, 1, and then multiply each by a power of 2, starting at 0 and just working your way up till you're done. So the problem that I need to solve is 1 times 2 to the 0 plus 1 times 2 to the 1 plus 1 times 2 squared plus 1 times 2 cubed plus 0 times 2 to the 4th plus 1 times 2 to the 5th. Now I'll do my exponents. 2 to the 0 power is 1. 2 to the 1st power is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. And 2 to the 5th power is 32. And then after I do the exponents, I do the multiplications. First multiplication, 1 times 1 is 1. Second multiplication, 1 times 2 is 2. Third multiplication, 1 times 4 is 4. Fourth multiplication, 1 times 8 is 8. Next multiplication, 0 times 16 is 0. Last multiplication, 1 times 32 is 32. And I just add these numbers up. Way safer to do it on my calculator. So I go 1 plus 2 plus 4 plus 8 plus 32. I don't need to put the plus 0 in there. And I get 47. So 1, 0, 1, 1, 1, 1 base 2 is equal to 47 base 10. And again, if I'm writing an answer to this, I'd probably just write down the number 47 and be happy with that. I very specifically skipped problem 16 because it was working in, I forget, base 12, and in base 12 you have a number that represents 11. I just want to get into that. So I'll do one last problem in this direction, taking a number from a base and writing it in base 10. And regardless of what the base is, you start off by writing the number backwards, and then you multiply each of the numbers by the base to an exponent, and the exponent depends on where the number is. So 14705 base 8, I started off writing 50741. I took the number and wrote it backwards. Then I multiplied by powers of 8, starting at 0, working my way up. And the first thing I do once I get the problem set up is do the exponents. Anything to the 0 power is 1. Anything to the first power is itself. And then the next one's 8 squared, I know, is 8 times 8, which is 64. 8 cubed isn't one that I know so well, so I'll hit my calculator and I go 8, up arrow 3. And for 8 cubed, I'm going to put 512. And similarly, 8 to the 4th isn't a power that I know so well. When I do 8 to the 4th on my calculator, I get 4,096. So I got the problem set up. Then I got rid of the exponents. Now I'm going to do the multiplication. 5 times 1 is 5. 0 times 8 is 0. And then 7 times 64 isn't something I could do in my head so quickly, so I broke my calculator out and got 448. 4 times 512 is also something I can't do that quickly. That's 2,048. And 1 times 4,096 is 4,096. I'm just going to add these numbers together now. So I'll go 5 plus 0 plus 448 plus 2,048 plus 4,096, and I get the answer. It's 6,597 base 10. So again, if I was writing an answer, I'd probably just write 6597. If you wanted to, you could write the problem. 14705 base 8 is equal to 6597, and you can insert the base, but it's not necessary. That's the easier direction. Taking a number that's not in base 10 and writing it in base 10, for me, is easier than taking a number in base 10 and writing it in another base. And that's the next skill we have to do. It's not terribly hard going backwards, but it's a little bit harder. And there are many ways to go backwards. and I'll just teach one of them, and if you don't like the method, I can show you another method individually, but I think this method for me is the easiest. So problems 21 through 36 give me a number in base 10, want me to convert it to another base. So problem 22 gives me the number 16 that's in base 10. It wants me to change it to base 2. Anytime I'm asked to convert to a base, oh, that's not a good problem. Let me do a made-up problem before I do that. Because this won't, that particular problem won't show any subtleties. Let me convert this. Let me convert 126 to base 4. So I know immediately, because I'm converting to base 4s, in my answer, the only numbers I can expect to see are 0, 1, 2, and 3. Because in any base, you can't have a number in that base that's equal to or greater than the base. So when I go to write this answer, 126 base 10, and make it into base 4, I'm cognizant knowing that I only can have the numbers 0, 1, 2, and 3 in my answer. To start off, to do this problem, I'm going to start writing down powers of 4, and I'm going to stop once I get to a number that's bigger than 126. So 4 to the 0 power is 1. 4 to the first power is 4 times 4, which is 4. 4 to the first power is just 4. 4 to the second power is 4 times 4, which is 16. 4 to the third power is 4 times 4 times 4, which is 64. And 4 to the fourth power is, if I did it on my calculator, I think I'd get 256. 256 is bigger than 126, so I'm not going to do any more powers of 4. In fact, I'm going to cross out the power of 4 that's bigger than 126. So I'm converting to base 4. I need to know powers of 4. My answer is going to have 4 slots in it, because there are 4 powers of 4 that are less than 126. So the number of digits in your answer is going to be the number of the base, the number of powers of the base that are less than that number. So there are 4 powers of 4 that are less than 126. My answer is going to have 4 digits. Now I'm going to find out what the answer is. And underneath my spots, I'm going to put the powers of 4 going in reverse. So the powers of 4 that I've come up with are 64, 16, 4, and 1. And writing these numbers under the dashes is going to help me write my answer. So I'm going to start with the number 126, and I'm going to subtract 64 as many times as I can without producing a negative. So if I subtract 64 once from 126, 6 minus 4 is 2, 12 minus 6 is 6, I get 62. If I tried to subtract 64 again, 62 minus 64 would be a negative 2. I can only subtract 64 once without getting a negative. Above the 64 in my answer, I'm going to put a 1 for the one time that I could subtract 64 from the base without producing a negative. I'm going to ignore the 126 for the rest of the problem, and I'm going to bring the 62 up, which was what I was left with after I subtracted. And now from that 62, I'm going to start subtracting the next number that I see, the next power of 4. So I'm going to go 62 minus 16. And if I do that without a calculator, I'll probably screw up. So I go 62 minus 16, and I get 46. I ask myself, if I subtracted 16 again, would I get negative? No. So I'm going to subtract 16 again. 46 minus 16, I could do that in my head, but to be safe, I'm going to get a 30. And I ask myself, if I subtracted 16 one more time, would I get negative? I'd say no. So I'm going to do 30 minus 16. And when I do that, I get 14. If I subtracted 16 again, 14 minus 16 would be a negative 2. So I can't subtract 16 again or I'd get a positive. So I'm done with this set, and I'm done with the 16. Above the 16, I'm going to write a 3, which is the 3 times I could subtract 16 from the 62. I'm done with the 126. I'm done with the 62. Now I'm going to start working with the 14. And from the 14, I'm going to start subtracting 4 as many times as I can without getting a negative. So I'm going to go 14 minus 4. I don't need my calculator for this. That's 10. Ask myself if I can subtract 4 again without making it negative. The answer is yes, so I'm going to subtract. 10 minus 4 will give me 6. I ask myself if I could subtract 4 again. The answer would be yes. And 6 minus 4 is going to give me 2. If I tried to subtract 4 again, I'd get a negative, so I'm done subtracting 4. I was able to subtract 4 3 times. So above the 4 where my answer is, I'm going to write a 3 for the number of times I could subtract it. I'm going to be done with the 14. I'm going to bring the 2 up, and I'm going to start subtracting the last number I see. So I'm going to go 2 minus 1 is 1. Can I subtract 1 again? Yes. 1 minus 1 is 0. And once you get to 0, you're done. I can't subtract 1 any more times. I was able to subtract 1 2 times. So I would say 126 base 10 is going to equal to 1332 base 4. Nicely, if you look at my answer, it doesn't have any number bigger than 4, and that's perfect. Still going to take a second before I do problem 22 because it's still a little bit tricky. It's a bad first problem. So let me do 24. And then I'll go back and do 22. So for 24, I'm converting to base 6. To convert to from base 10 to any base, you start off by writing the powers of the base. 6 to the 0 power is 1, because anything to the 0 power is 1. 6 to the first power is 6. 6 to the second power is 6 times 6, which is 36. 6 to the third power, I'm pretty sure it's 216, but I'll make sure that it is. I go 6 up arrow 3 on my calculator, and it's 216. 6 to the fourth power, 6 up arrow 4, is 1,296. I go until I get a number that's bigger than what I'm converting from. I'm converting 243 base 10 to base 6, and I wrote all the powers of 6 down until I got a number bigger than 243. Scratch that number out. Now I'm going to get ready to write my answer. My answer is going to have a spot for how many times I could subtract 216. It's going to have a spot for how many times I could subtract 36. It's going to have a spot for how many times I can subtract 6. And a spot for how many times I can subtract 1. So because there are 4 powers of 6 that are less than 243, my answer is going to have 4 spots again. That's not always going to be the case, but in this case it is. So once I know that my answer is going to have 4 digits, I start subtracting. I take the number that I'm given, which is 243, and I start subtracting. The biggest power of 6 that's less than 243 is 216. I subtract once. 243 minus 216 is 27. If I tried to subtract 216 again, if I did 27 minus 216, I'd get a negative number. So I'm done subtracting 216. I was only able to subtract 216 once. So above 216, where my answer goes, I'm putting the 1 time that I could subtract it. I'm going to bring the 27 over. What I'd like to do with the 27 is to subtract 36. But if I subtracted 36, I'd get a negative number. And what I'm writing in my answer is how many times I can subtract that number without getting a negative. And 27 minus 36 gives me a negative. I wasn't able to subtract 36 even 1 time, because if I tried to subtract 36, I'd get a negative number. So I'm never going to subtract 36. And above the 36, I'm going to write a 0 for the number of times I was allowed to subtract it. Still working with the 27 because I haven't subtracted a number from the 27. I'm done with the 216. I was able to subtract it once. I'm done with the 36. I wasn't able to subtract it at all. Now I'm going to work with the 6. So I'm going to go 27 minus 6 is 21. 21 minus 6 is 15. 15 minus 6 is 9. And 9 minus 6 is 3. If I tried to subtract 6 again, I'd get a negative. So I'm done subtracting 6. And I subtracted 6 1, 2, 3, 4 times. So above the 6 where my answer is, I'm going to write a 4. Now I'm done subtracting 6. I'm done with the 27. I'm going to carry what's left, which is the 3 up, and start subtracting 1. I'll go 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Once I get to 0, I'm done. The number of times I was able to subtract 1 was 3 times. So I would say that 243 base 10 is equal to 1043 base 6. The answer to this problem is 243 base 10 is 1043 base 6. This is good because in base 6, the only numbers I'd have been permitted to have are 0, 1, 2, 3, 4, and 5. Because in any base, you could have 0 up to 1 less than that number. If I had a number that was 6 or bigger, I would have had a mistake. Still not that excited to do 22. Let me do one more problem and then go back to 22. And maybe you can do this problem without my assistance. That would be fantastic. So for any problem that I'm converting to a base, I start off writing that base with every exponent until I get a number that's bigger than my starting number. So this is base 4. So I'm starting off writing all the powers of 4 that I can think of. So starting at 0, ending wherever it can end. 4 to the 4th power is 256. That's okay. 4 to the 5th power is 1024, and that's too big. So for each problem that I'm asked to convert into a base, I start with that particular base and write all the powers of it until I get to a power that's bigger than the number that I'm working with, and I cross that out. So I started with 4 to the 0, got up to 4 to the 5th. 4 to the 5th was too big. It's bigger than 908, so I'm not going to write it. My answer is going to have 5 different numbers for the number of times I can subtract each power of 4 that's less than 908. So I wrote down all the powers of 4 that were less than 908 and made my answer. My answer is going to have 5 digits in it, and the first digit is going to be the number of times I can subtract 256. So I'm going to take my number that's 908 and start subtracting 256 and find out how many times I can subtract it. Use my calculator for this, so I'm going to go 908 minus 256, and I get 652. I'll try to subtract it again, so I go minus 256, and that gives me 396. Try to subtract it again and get 140. If I tried to subtract it again, I'd get a negative, so I'm done subtracting 256. In my answer blank, I'm going to write above the 256 the number of times I was able to subtract 256. In this case, it's 3. I'm done with the 908. Now I'm going to start working with the 140. With the 140, I'm going to start subtracting 64. So I'm going to go 140 minus 64, and I get 76. Then I go 76 minus 64 and get 12. I can tell that if I tried to subtract 64 again, I'd get a negative. So I'm done with the 64. Where my answer goes above the 64, I'm going to write a 2 because I was able to subtract 64 2 times. I'm done with the 908. I'm done with the 140. Now I'm going to start working with the 12. The next number I'm supposed to subtract is 16. If I try to subtract 16 from 12, I get a negative 4. So I'm not allowed to subtract 16. I'm going to say I can subtract 16 0 times. Done with the 16 because I wasn't able to subtract it, but I did put a 0 in its spot because I need a spot for every number. Now I'm going to start subtracting 4. I'm going to go 12 minus 4 is 8. 8 minus 4 is 4. And 4 minus 4 is 0. And that's not negative, so I can subtract 4 3 times. So above the 4, I'm going to write a 3. Bring up my 0, and I ask myself, how many times can I subtract 1? Well, even if I subtracted 1 even once, I'd get a negative. So I'm not able to subtract 1 any times because after I subtracted 4, the number that was left was 0. And if I started to subtract 1 anytime, I'd get a negative number. So I'm not allowed to subtract 1. But above the 1, I need to put the number of times I can subtract it. In this case, it's 0. So in this particular problem, 908 base 10 is equal to 32030 base 4. And the answer to problem 26 is 32030 base 4. Again, good thing, because in base 4, the only numbers I'm allowed to have are the numbers 0, 1, 2, and 3, and that's all I see in my answers. I don't see a 1, but that's okay. But I couldn't have a number that's 4 or larger. Still going to hold off on that 22, and let me do 28, which is another lovely base 4 problem, and see what we can do here. So for 28, I'm going to start off. I need to find out how many spots are going to be in my answer. I do that by writing down the powers of 4 until I get to a number that's bigger than 200. So the powers of 4 are 4 to the 0 is 1, 4 to the 1 is 4, 4 squared is 16, 4 cubed is 64, 4 to the 4th is 256. I cross out the 256 because it's too big, and in my answer blank, I'm only going to subtract the numbers 64, 16, 4, and 1. I start off with the number 200, and I start subtracting 64. Safe to do this on your calculator, so I'm just going to use my calculator. I'll go 200 minus 64, and I get 136. And then I'm going to minus 64 again and get 72. And then I'm going to minus 64 again and get 8. So I was able to subtract 64 3 times. If I subtracted 64 again, I'd get a negative. So I'm stopping subtracting 64, writing 3 on my answer blank above the 64 for the number of times I could subtract it. I'm going to bring my 8 up. If I tried to subtract 16, just like in the last problem, I'd get a negative. So I'm not allowed to subtract 16 any times, but I need a number above the 16. I'm going to put a 0 because I wasn't able to subtract it. I'm going to bring my 8 over and start subtracting the next number that I see, which is 4. I'm going to go 8 minus 4 is 4. 4 minus 4 is 0, which isn't negative, so I was able to subtract 4 2 times. Done with the 4, bring the 0 up. If I try to subtract 1 even one time, which is the next number, I get a negative number, so I'm not allowed to subtract 1. Above the 1, I'll write a 0 for the number of times I could subtract it. And I would say 200, which is the original number, is 3020 base 4. Okay, now I'm going to go back and do problem 22 that I skipped over. Problem 22 wants me to convert 16 to base 2, and let me just do this on the sheet here. So I want to convert 16 to base 2. So I'm going to start off writing my powers of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. That's too big. So I wrote down all the powers of 2 that were 16 or less. And now I'm going to write my answer. My answer is going to have a spot for each number in this right-hand column. And above that, I'm going to write the number of times I could subtract it. So I'm going to start with this number 16. The first number I'm going to subtract is 16. 16 minus 16 is 0. If I tried to subtract 16 again, I'd get a negative, so I was only able to subtract 16 one time. If I bring the 0 up, if I tried to subtract 8, I'd get a negative, so I'm not allowed to subtract 8 anytime, so I'm going to write a 0 above the 8. So I'm done with the 8. If I tried to subtract 4 anytime, which is the next number on my list, I'd get a negative number, so I can't subtract 4. So I put a 0 above the 4 for the number of times I could subtract it. If I tried to subtract 2, even one time, I'd get a negative number, so I can't subtract 2. And if I tried to subtract 1 from that 0, I'd get a negative number, so I can't subtract 1. Once you get to a 0, every number after it in your answer is going to be a 0. But you have to have a place in your answer for every power of the base that's less than the number that I'm starting with. So my answer to number 22 is 16 is equal to 1 and then 4 zeros base 2, or 16 base 10 is equal to 1, 0, 0, 0, 0 base 2. So this is the reason I skipped over this problem, because I felt it was a little bit tricky for a first problem. The author put this first because the way the author teaches how to do this, this lends itself really nicely to the way the author does the problem, but not as nicely to the way I do the subtraction. So, but the answer when you're converting to a base has to have a slot for every power of the base that's less than it. So my answer in this case had to have 5 spots. Even if those spots were filled up with zeros, I still needed to have those spots. 30 is the same sort of, I have the same sort of issue with number 30 that I just did. So if I'm doing problem 30, hopefully you can pause the video and work this. I start down and write my powers of 3. 3 to the 0 is 1. 3 to the 1 is 3. 3 to the second power is 9. 3 cubed, I don't need my calculator for, but you can use your calculator if you don't know that 3 cubed is 27. 3 to the fourth power is 81. 3 to the fifth power is too big, it's 243. So I wrote down all the powers of 3. I finally got one that was bigger than the number I'm starting with. I crossed it out. My answer needs to have a spot for every single number that's a power of 3 that's less than 81. So my answer has to have 5 spots. This problem is going to be a lot like problem 22 in the form. Its answer is going to have a lot of zeros. So now I start with 81. I start subtracting 81. After I subtract 81 one time, I get a 0. So I'm going to put a 1 above the 81 because I was able to subtract it one time. And then the rest of the numbers are going to get zeros above it, because from 0, if I tried to subtract 27, I'd get a negative. From 0, if I tried to subtract 9, I'd get a negative. From 0, if I tried to subtract 3, or if I tried to subtract 1, I'd get a negative. So for any one of these next numbers, you try to find out how many times you can subtract them without getting a negative, and none of them can be subtracted, because if I subtract even 1 from 0, I get a negative. So for the rest of the numbers, 27, 9, 3, and 1, I put a 0 above them, because if I subtract them even once, I get a negative. So my original problem, 81 base 10, is equal to 1, 0, 0, 0, 0 base 3. And you can't just write 1 base 3. You have to have all those spots. If you didn't have those zeros in there, if you try to convert the problem back to your answer, it wouldn't check. Can't have too many more here. And there's nothing new. So if you feel good about this, then that's fantastic. If you don't, continue watching. 32 is a nuisance because 4,312 is a big number. I don't know my powers of 6 really well. But for each one of these problems, I start off exactly the same way. I start writing the powers of the base, and when I don't know the powers of the base, I use my calculator. And once I get to a power that's bigger than the number that I'm interested in, I stop. So I started this problem by writing all my powers of 6, and I finally got a number that's too big. I cross out the 7,776 and get ready to write my answer. I make a spot for each number that I'm subtracting. I figure out how many times I can subtract them. So I take the number 4,312, and now I'm going to start subtracting 1296. I'm going to subtract it as many times as I can without getting a negative. So I'll go 4312 minus 1296 and get 3016. Subtract it again, and I get 1720. And subtract it again and get 424. If I try to subtract it again, I'd get a negative. So above the 216, above the 1296, I'm going to write a 3 because I was able to subtract it 3 times. I'm going to bring the 424, which is my remainder, up and start subtracting 216. So I'm going to go 424 minus 216, and I get a 208. If I tried to subtract 216 again, I'd get a negative. So I was only able to subtract 216 once. Above the 216, I'm going to put a 1. And now I'm going to carry the 208 over and start subtracting 36. So I'll go 208 minus 36 and get 172. I'm going to go minus 36 again and get 136. Minus 36 again and get 100. Minus 36 again and get 64. Minus 36 again and get 28. If I tried to subtract 36 one more time, I'd go negative. So I was able to subtract 36 1, 2, 3, 4, 5 times. In my answer above the 36, I'm going to put a 5. Done with the 36, bring up the 28 and start subtracting 6. 28 minus 6 is 22. 22 minus 6 is 16. 16 minus 6 is 10. 10 minus 6 is 4. If I tried to subtract 6 one more time, I'd get a negative. So 1, 2, 3. There were 4 times I was able to subtract 6. So above the 6, I'm going to put a 4. And now I'm going to bring the 4 up, which is this remainder, and start subtracting 1. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Once I get to 0, I can stop. And I was able to subtract 1 4 times. So the initial problem, 4,312, is equal to 31544 base 6. And I'll do just one more. And if you stop the video now because you feel good about this, it's not going to hurt my feelings at all. So the last problem I'm going to do is 34. I have a 36 written down, but it just feels like this has got to be enough. So for 34, it's base 7. I start writing my powers of 7. 7 to the 0 power is 1. 7 to the first power is 7. 7 to the second power is 49. 7 to the third power, I'm not so good with 7, so I'll use my calculator. 7, up arrow 3, and get 343. 7 to the fourth power, I think it gets too big. 7 to the fourth power is 2,401, which is too big. So I'm going to cross out that 2,401, and in my answer, I need to subtract 343. I need to subtract 49, I need to subtract 7, and I need to subtract 1. Start with my 1589. Start subtracting 343. Definitely, I'll just do this on my calculator. It's easier and quicker. So 1589 minus 343, I get 1246. Subtract 343 again and get 903. Subtract 343 again and get 560. Subtract 343 again and get 217. If I tried to subtract it again, I'd get a negative. So it's 1, 2, 3, 4 times that I could subtract 343. So in my answer, I'll write a 4 above the 343. Bring the 217 up and start subtracting 49. So 217 minus 49 is 168. Minus 49 is 119. Minus 49 is 70. Minus 49 is 21. If I tried to subtract it another time, I'd go negative. So I'm able to subtract it 1, 2, 3, 4 times. So above the 49, I'm also going to put a 4. I'll bring the 21 up and start subtracting 7. 21 minus 7 is 14. 14 minus 7 is 7. 7 minus 7 is 0. I subtracted 7 3 times. If I tried to subtract 1 from the 0 that's left over, I'd get a negative, so I'm not allowed to subtract 1. So above the 1, I'll put a 0. And my answer to this problem, 1589 is 4430 base 7. And I had intended to do problem 36, but I hope that this was enough of these. If not, I can do 36 in class. You would start off, it's a bad problem, but you'd write 8 to the 0 all the way up to maybe like 8 to the 5th power. Subtract the powers of 8 until you fill in all the spaces. All right, so hopefully that was tolerable.